Hello, in this video I will to talk about of this paper called Physical and Mechanical Properties of Hemp Fiber Reinforced with Alkali-activated Fly Ash and Fly Ash Mortars. Concrete is the most widely used material on Earth. Producing it requires mine resource and high energy, which generates great pollution. Then it is necessary to look for alternatives that can replace it. Natural fibers seem to be a good alternative to improved materials with low resistance, but long-term performance must be evaluated. The mortars were made with fly ash and byproducts from various industries, and were grouped according to their composition. In the figure, you can see each of them. For the study, hemp fibers were dried and cut from a 10 mm long bundle separated by hand before mixing and added to the mortar matrix. Two types of meats were designed in terms of density and compressive strength. For this, the different compounds of ash and hemp were evaluated looking for an optimal relationship that would give good results. Experimental campaign. A mineralogical analysis was performed on the samples, but without hemp fibers to measure S-ray powder diffraction record. The water absorption is evaluated at 28 days of curing as well as the tensile and compression test to obtain the trace of the hemp fibers. The microstructural analysis was used. Results. Chemical analysis. In both samples, there is quartz for sand, mullite from fly ash, and calcite for natural carbonation. The presence of slag in the molar matrix contributes to generating amorphous products and therefore a more compact structure. In the figure, you can see the results for the X-ray diffraction for the samples Fe1 and Fe2s. Physical properties. A decrease in the density and the increase in the water absorption of the samples were reported when using hemp fibers. However, the densities increased on the mortars with fly ash. In the figures, you can see the densities and amount of water absorption according to the fiber dose. Mechanical properties. It was evident that when implementing natural fibers, the compressive strength decreased due to the fact that the porosity increased and the density decreased, and the contribution to the tensile strength is minimal. In the graphs, you can see how certain properties increase or decrease for different samples according to the fiber dose. At the conclusion of the study, it was evident that mortars with hemp fibers can become a viable replacement for cementitious materials. The Fe2s series with fibers and blast furnace ash showed a significant improvement to the all parameters evaluated. The figure shows a comparison between the samples that obtained the best results. The Fe2s sample beat the one that gave the best results. In this electron microscope image, you can see the comparison of the matrix of both samples. You can see how the Fe2s sample have a better interface, with less porosity due to the thinner fibers. Thanks for your attention.